So the objective of today's lesson is estimating products and making magnitude estimates. A magnitude estimate is just a very rough estimate of the answer to a problem. So there's a couple times when making a magnitude estimate comes in really handy. Sometimes you don't need to know the exact answer. You can save a lot of time by making a magnitude estimate and just getting kind of close to the right answer. Magnitude estimates are also good at letting you know the reasonableness of your real answer. Say you solve a problem and end up with an answer that's in the 10,000s, but you did a quick magnitude estimate and it told you that you should have ended up with an answer in the thousands. That's a big red flag that you need to double check your calculations. So let's look at this example, 117 times 490. One question that students always have is how much rounding should I do? On a problem like this, would it be appropriate to round to the tens place or should you go ahead and round to the hundreds place? A good rule of thumb is that when you're done rounding in a magnitude estimate, you should be left with numbers that are easy to multiply in your head. So let's look at this. We're going to round to the hundreds place. That's going to give me numbers that I know that I'm going to be able to multiply in my head. So 117, if I round to the hundreds place, it's either going to stay at 100 or it's going to get rounded up to 200. Since 117 is closer to 100 than 200, we're going to round to 100. 490 is going to get rounded up to 500 because if I look at the tens place, it's a 9. 9 is greater than 5, so 490 rounds to 500. I now have numbers that are easy to multiply. 1 times 5 is 5, and I've got 1, 2, 3, 4 zeros. 1, 2, 3, 4, and I have my final answer, 50,000. So what if I had made a different decision about how to round? What if I had decided instead of rounding to the hundreds place, I want to round to the tens place? 117 then would have become 120 because 117 is closer to 120 than it is 110. My 490 actually would have become 500 anyway because 49 is closer to 50 than 40. And I would have had the multiplication problem 120 times 500. Now, if you know your 12s place, this is not a difficult problem. It's 60 is the answer to 12 times 5, and I've got 1, 2, 3 zeros. So when I rounded differently, I ended up with a slightly different magnitude estimate, but notice it's still in the 10,000s. It's still about the same amount. So you can get a little closer, you can get a more accurate magnitude estimate by rounding to a smaller place value, but if it gives you a number that you can't do in your head, then that's a good indication that you need to round to a greater place value. And it's perfectly okay in magnitude estimates to round to the highest place value. So when you're doing these problems in your math book, you're going to see something that looks a little bit like this. You'll see a problem, in this case 57 times 12, and then below it you'll see this box. The boxes in your book are a lot neater than this, with different place values in it, tens, hundreds, 1000s, and 10,000s. That's for circling the area that your magnitude estimate falls in. So let's do a practice problem that's just like one in the book. First we're going to round 57. We're going to round it to the greatest place value, which is the tens. Is 57 closer to 50 or 60? It's closer to 60. 12, is 12 closer to 10 or 20? It's closer to 10. Simple multiplication problem now. 60 times 10 is 6. 2 zeros, make it 600 is my final answer. So in these boxes, I'm going to circle hundreds because I'm expecting to get an answer that's in the hundreds place when I do a real calculation. Okay, so we're going to look at one last example before you're ready to go do some independent practice. This problem is 4.5 times 0.6. Let's look at the first number, 4.5. Now the greatest place value is the ones place. When we do magnitude estimates, we absolutely don't want to have any decimals in the numbers that we're trying to multiply. Getting rid of those decimals is the first thing we need to do before we make a magnitude estimate of any kind. So when we round 4.5, we want to make sure we end up with a number that's easy to multiply that does not contain a decimal. Well, this is the ones place, and right now it's a 4. 4.5, is that closer to 4 or closer to 5? It's right in the middle, but the rule is if the number following the number we're rounding to is 5 or greater, we round up. So we're going to go ahead and round back to a 5. This 0.6, we also need to round. We don't want to have a decimal though, so we want to get rid of everything on this side of the decimal point so we can not have a decimal. So since this is a 0 in the ones place, we don't even have any ones. 0.6 is more than a half though. If it was money, it would be 60 cents, 6/10. So we're going to round 0.6 to just 1 whole. It's closest to 1 whole, which gives us the very simple math problem 5 times 1, which is 5. And that's the final answer for the magnitude estimate. Our boxes, which have changed a little bit, you probably notice, now are the tenths, the ones, the tens, and hundreds. We ended up with an answer of 5, which is in the ones place, so we're going to circle ones. We know that if we were to actually solve this real problem, 4.5 times 0.6, our final answer should be in the ones. This problem is actually problem number 6 on page 47 of your math journal. This exact problem is problem number 6 on page 47, and page 47 is the page, that was my dog, page 47 is the page I would like you to go do now for practice. Now the ones with decimals are more difficult, they're a challenge, but do your best, do all the ones that you can, and if you have a problem with any of them, come to school tomorrow morning prepared to talk to your teacher about it, okay? And that was my dog shaking his collar. Good luck.